Hi everyone. In this video, we'll be going over SLLists, but let's begin with a bit of motivation. So, what is the problem with linked lists? We already touched upon the problem of slow random access, but uh, not as easy to see problem is that int lists are kind of tedious to use, right? What I mean by that is, let's say we have a user who wants a list to store numbers. Well, an int list is the perfect solution to this, right? So let's give them an int list. Well, the user is going to be confused, right? Who understands the recursive nature? It's very tedious, right? Only like 61BL students have that capability of understanding the recursive nature. So this user might be confused. So in this case, we kind of see that a problem with linked lists is that they're sometimes tough to use. Users need to know how to think recursively, how to store references to int lists. So there must be a way to kind of abstract some of this away and make our users' life easier, okay? And that's the motivation from going from an int list to an SL list, okay? So before we get to an SL list, let's first make one small improvement and rename the int node class, the int list class to int node, okay? The int node is very minimalistic. It doesn't have any methods, and we will see the functionality on this slide, okay? So this slide is very important. It's, I think, the most important slide in this lecture. And what we're doing here is we're introducing the idea of encapsulation. We're taking this int list, changing it to an int node, and making that int node an attribute of the SLList class. And what that does is it successfully makes the SLList like a wrapper around this int node. So what we can do is we can execute operations on this int node using functionality from the SLList class. And that's going to be much easier than using the int list class, as we'll soon see. Okay, so let's just look at a basic implementation of the SLList class. So we have a constructor. We have our attribute first, which is the first int node in our linked list that we're storing. And we also have the methods add first and get first, okay? So we can see in the bottom right corner that the SL list is easy to use, right? Adding the numbers 15, 10, and 5 is pretty straightforward because I can just call the add first method. And if I want to find what's at index 0, I can call get first. On the other hand, when we look at the int list, it's a bit more tedious to achieve that same result, right? I have to create an int list L that's equal to a new int list. And then, yeah, it's messy. It's not easy to code versus the code on the left-hand side. So the obvious question to ask here is, why can't we add an add first method to the int list class, right? So it turns out there's no efficient way to do this, and I'd recommend pausing the video here, really thinking about why that's the case. Okay, so let's kind of walk through this together. So suppose that we have some int list L, okay? So we have some int list L, and let's say it contains the values 1, 2, and 3, okay? So if I wanted to have an add first method in the int list class, it would probably work like so. Where I do L.add first 0, and what we expect to happen is that we have a 0 node in the beginning here, okay? So the main problem with this is that if I do L.add first 0, we need to actually reassign the value of L so that L points here. Do you all see that? So in this add first method, it's impossible for us to reassign the value of L, right? All I can do is change like the attributes of L, but I can't actually reassign L to this new node. And that's the reason why we can't have that add first functionality in the intlist class, but we can have it in the SLList class. Okay, so let's kind of look at a visual of the same idea here. So at the top, we're looking at the intlist class, and this is, if I give it to a user, this is how they would have to interact with it, right? They might have to store variables that point in the middle of the intlist. It gets kind of confusing. On the bottom, on the other hand, we can see the SLList is like a middleman between the user and our linked list, our raw data structure, okay? And it makes it much easier for us to interact with this list that we have. All I have to do is know the functionality that SLList class has to offer, right? What I mean by functionality is like the add first, the get first, these methods of the SLList, and it makes life so much easier, right? So going back to our initial problem, if we have someone who wants a list to store numbers, I can say, here's an SLList. It has this functionality. It has add first, remove first, size, get. And now it's easy to use. I don't need to understand the intricate recursive nature of the linked list. I can just say, here's an SLList. It offers this functionality. Your life is easier now. Okay. So a quick teaser for the next video is that should the user even know the int list exists, right? Right now, they can kind of see there's like some int node first there. So yeah, can we kind of abstract that away? So yeah, get excited for the next video and I'll see you shortly.